Hello everyone, welcome to Programming Knowledge. So I again welcome you all to yet another tutorial at Programming Knowledge. So in today's tutorial we are going to cover about graph theory. So let's go with our next topic. But before that you can go to our repository and download all the code available in Python prior to this tutorial. So let's get started with today's tutorial. So today's tutorial we are going to learn about topological sort. So topological sort via a source removal algorithm. So basically source removal algorithm is a technique to implement topological sort. So before we proceed to topological sort, we need to remember few points. That is, the graph should be DAC, that is directed and acyclic. So basically it should be directed and acyclic. So basically the graph should be first directed a graph and it should be acyclic. And what does topological sort means? For every edge u to v, u will come before v in the ordering of the graph. Okay, so and then we have a term called in degree, that is incoming edges on the node. And there is also a term called out degree, that is outgoing edges of the node, but we don't deal with it during the topological sort. So hence we need to remember 3 points. First, it should be directed and acyclic. Then for every edge u to v, u will come before v in the ordering of the graph, and this ordering is known as topological ordering or topological sort. And in degrees incoming edges on the node. Okay, so let's move to further. Now we have a graph. Now we implement the source removal algorithm. First we need to look the node with minimum in degree. So you can identify the node with the minimum in degree is, that is the node b. So we take node b. So let's write node b here and remove node b and all the edges associated with it. So here we remove b and all the edges associated with it. Now we have a node with minimum degree is a. So let's write here a here. Either you can read first or write first, it doesn't matter. Now we remove a and all the nodes associated with a. Now we remove the node with minimum degree. So basically now what we can calculate the in degree. Suppose uh, this has 2 in degree, this has 1 in degree, sorry, 1, and this has 0 in degree. So we remove d. Like this is the way we remove. Okay, now let's remove d and all the edges associated with d. Now we remove d. Like this process goes on. BAD. Now we have C and E. So here you can see the node with the minimum in degree is C. Then we remove C and all the edges associated with C. Now we remove E in the end. So before we remove E, let's me write C here. Sorry, C, and then when I remove E in the end, then E will come end. So I also remove E. So this is the main topological sort of our graph. So here it follows like the for if there was a edge to B to A, then B will come before the A in the ordering. So it follows this rule. U will come before V in the ordering of the graph if there exists the edge U to V. So this is the topological sort. So basically topological sort is a linear ordering, and we try to solve this in a linear time. So basically what we are going to implement breadth first search, which is linear in time, and the time complexity will be O big O of V plus E. So time complexity is equal to big O V plus E. So we are going to use BFS. So let me show you the test cases of this graph. Yeah. So this is the test case of our graph. This is the similar one which I had. This is the graph which I had shown you. So that is A to C, A to D, B to A, B to D. So here you can see A to C, A to D, B to A, B to D, then C to E. So we have C to E and D to C and D to E. So it satisfies all the conditions. Now let's implement this algorithm. So this is already I've made the template how to take input from the graph. So it would save us time and we could concentrate on the logic part. So let's continue with the code. So we will implement, like, first we need to make a note of the degree. So degree, we have to make the node of the degree, and here you can see that for I will also pass v here. Okay, there's a small issue in this code. I need to change the variable name vertex comma e, and I will send g comma vertex, and here I will take g comma vertex. Now I will implement a array which will take a note of all the degree. So degree is equal to 0 star vertex. Now for node in G, if there is a node in G, for adjacency node in G of node. So here you can visualize the adjacency list. Then I need to increment the degree. Then degree, because this is an outgoing edge but an incoming edge for the adjacency node. Like, here you can imagine that from there will be a going edge from node to adjacency node. So degree of, since this is an outgoing edge from our node but an incoming edge for adjacency node, then we increment the degree of adjacency node by +1. Okay, so this is what we do. So degree of adjacency node plus equal to 1. So we increment the degree of adjacency node. So by this we keep a track of all the degree of the nodes. Now we need to start with the node. We will do BFS. So we'll take a queue here. So this is we can start with the node which has 0 in degree. So what we can do, we can do I for I in range vertex if degree of I is equal to 0. So this would implement a queue which has 0 nodes with 0 degree. So this would be the initial node. For our case in the graph it was B. Now what we can do, so for node, for every node in BFS, we can say, then for adjacency node of G of node, we move to adjacency node, and now we decrease the we decrease the degree of the adjacency node because we are removing the edges. Remember the case when we also used to erase the edges. Then if we erase the edges, then the degree of adjacency node becomes 0. Okay, now if degree of adjacency node is equal to 0, then we iteratively call this for topological sort. Then in the end we return this BFSQ. Okay, now degree is equal to 0 star vertex. For I'll explain you again. This would give you a quick overview. Like for every degree, first we make an array which keeps a track of degree. Then for node in graph, then for adjacency node in graph of node, we do degree of adjacency node plus equal to 1. So this is the one part. Then we initialize a queue which has a degree 0. Then for node in BFS, for adjacency node in graph of node, degree of adjacency node, we decrease the degree if we remove the edge. But while removing the edges, if we come across a node which has 0 degree, then we iteratively call this for topological sort. Then we return this queue. Now let's run this algorithm. Now let's run this algorithm. Now, okay, for I in range E. Now let's run this algorithm. Yeah. Okay, I have an issue with this graph. So I have rectified the error. Basically, the error was like I had already made the template, but I had to. This was not for alphabetics. That was for integers. But now I have converted this to from I to for the alphabetic code. Since I made the values using the ASCII values, then I converted back to them. So basically, now here you can see I can run this code. I'll copy these test cases and I'll move to the code. Now run this code. Now here you can see when I put the test cases, I get the order which was expected. Basically, an error which I had was that the first I made the code for the integer values, but since in the input I had characters, so I converted them to the using the ASCII value. Then I reverted them by them again using the ASCII value. So it was a change. So here you can see the code, and you can implement the code. And thank you guys. Thank you for watching my video. So I'll catch you in the next tutorial.